Hey YouTube, it's JP Dillon. Today we're looking at a 1971 Sansui Model 2000X. And this was a fairly common model of the day. Very nicely built basic receiver. You can see it's disassembled right now. And the reason why it's in today is because there's no FM stereo. Now I know what you're thinking. Well, the light's lit up, right? It's receiving. And if I tune off the station, the light goes out, but there is no audible stereo separation. And I'm hooked up to my SoundTech 1000 here, and you can see I've got it selected so that the right phase would only be playing, but we've got two channels. And if I switch over to the left, there's absolutely no change. Left channel has a little bit more amplitude than the right, so I should be seeing a difference there, and there is absolutely none. Now, that points to the demodulation section. An abbreviated version of how a stereo multiplex works is you have a 19 kilohertz pilot signal, and the pilot signal contains phasing information once doubled. So the 19 kilohertz comes in, goes through a doubler circuit, and is turned into 38 kilohertz, which is then matrixed, usually into a set of 4 diodes, and a de-emphasis network that splits the two phases, the left and the right. There's usually a fine adjustment to, null out any monaural blending information. So I can pretty much discern that the 19 kilohertz section is still working, because if I go over to the signal generator here and I turn off the pilot signal, stereo light goes out. Turn on the pilot signal, stereo light comes on. So that tells me that the initial stages of the multiplex are working. So let's take a look at the schematic diagram and let's see what our possibilities are. Now here's a simplified diagram that they include in the serial or the service manual. And you can see that you've got the composite signal that comes in, goes through the amplifier, a tuned circuit, and then it goes through the 38 kilohertz amplifier, and then is tuned and demodulated through the 4 diode matrix as you see there, and then through a sharp cutoff, and then to the output. And then you've got your separate, which is the noise blender when the DC amps that trigger the stereo indicator. That's an abbreviated version, pretty much how I looked at it. So let's actually go to the real schematic diagram. And this is what it really looks like. So the things that could combat the problem, or not combat the problem, things that could cause the problem anomaly. You have a switch, and the purpose of the switch, they're taking a center tap here off, and they're running it down to a switch here, which is your turn on, turn off. And what that is supposed to do is turn on your lamp, which is your lamp driver circuit over here, and it's also supposed to start the diode switch up here, your matrixing. So this point, this transistor is supposed to turn on, and that's then fed from a control from this switch. So when this goes high, it pulls down on this. At least that's what I would think. Or maybe I'm wrong about that. Because this is coupled via capacitor, so this directly wouldn't be driving that. This looks like a threshold adjustment for turning this on. This is switched on by that. So you have the 1 in 34 set there, which is taking the sampling from the 38 kilohertz and switching that on and then turning the lamp on. So we're getting everything good up to here. So my thought is this 2SC536 here is either open or is not getting a proper signal or DC voltage to turn on, and that's why we're not demodulating. Because we've got our lamp drive here, which is present. We've got our switch, which is present. Our pilot's obviously present. And so let's take a look at TR403, and let's see what voltages we're getting on TR403. All right, so here's the board, and TR403 is this little gumdrop thing in question down here. So let's grab our meter, and let's see what voltages we've got there. let me just grab a test lead so that I can properly ground myself to the chassis. And I'm going to zoom out a little bit here. Okay, now let's take a look at TR403. On the base, we're supposed to have 3.6 volts. There it is. On the emitter, I'm supposed to have 3 volts. I got nothing. And our supply voltage is supposed to be on the collector, and there it is. So, nothing coming out of the emitter. Let's make sure there's no short to ground. Nope, 36K. So that transistor is open. So we need to replace that part. Okay, so here's the bottom side of the board. And just looking up top here, I think that this guy here, the little delta formation here, is going to be our TR403. So, iron's hot. Let's go ahead and pop this guy out. All right. I'm going to go from the other side here and give a good yank. Assuming I can get my fat fingers around it. And there it is. It's out. And let's pop a new one in. I'm just going to use a KSC 1845. That's a nice little multi-purpose transistor. Let me grab one here. And there we are. It's just this guy right here. These are made by ON Semiconductor, and they work wonderfully. Nice low noise, low leakage transistor. So I'm going to go here on the back side and pop it in, or attempt to at least. I may have to get some hemostats because this is a pretty tight area to work in. Taking it out is easier than putting it in, that's for sure. Alright, so there it goes. And let's grab our Kester 6040. That one's not quite complete. We'll come back to that lead. All right. Wants to be a pain. Then we'll get the flush cutters and we'll trim off the excess garbage. All right. So she's in there. Do a little scrapey between the leads, get rid of some of that excess flux in there. In fact, if we want to go a step further, we can actually clean the board work. A little bit of isopropyl and a brush. And we'll just clean all that garbage away. We should be good to go there. Okay. Now let's turn it on and wait for the moment of truth. Alright, so there it is back in the circuit. Let's go ahead and turn this on. And let's check our progress here. And as we can see on the scope, we now have a difference. So the right's better than the left. If I switch to the left, it becomes opposite. However, we still see a lot of bleed through there. So we need to do some tweaking. Now, you can follow the alignment steps. It does take considerable more time. But let me show you the quick and dirty alignment method. And it is good that you have a decent FM generator. like the Soundtech 1000. This is just a wonderful machine. Then I have a leader, and I have a, God, what was the other one? I'm trying to remember what the name of the other one is. Anyway, common piece of equipment. Maybe it's an HP, I don't know. But I like this because it's just so simplified. So what we're going to do first, I'm going to take a scope lead here, and we're going to come down onto the board. And usually on these Sansuis, we want to come to the, just at the end of the 19 kilohertz amplifier. So in that case, we want to look at the input to TR402 and see what size our 19 kilohertz is. So TR402 is this guy here. And I apologize for the camera location, but that's where we're going to be able to set it. It's another one of these evil little top hat transistors. I'm going to bend this back slightly, if I can do that. Nope, really can't because it's delta formation there. I'm going to try to attempt to attach my scope lead to this. Mini hook it. All right. So now what we do is we come back here, and let's crank this to the standard. The scope's going to mess with the switching, so don't worry about that. I'm going to switch off this, and we're going to take a look at the size of that 19 kilohertz pilot. Let me kill the modulation, so that's all we see. And then I'm going to get an alignment tool. Bear with me just a moment. And we're going to adjust the 19 kilohertz input. So I'm going to want to peak T401. So T401 is here. It's labeled wrong. It's T403 there, but then there's also T403 back there. So this is T401. And we're going to adjust this to peak the 19 kilohertz. We can see it gets smaller, and it gets larger, and then it starts to fall off. So that's our peak right there. So that's our 19 kilohertz, and we're going to leave that be, and we're going to move on to the next stage. And so then what we want to do is we want to measure from the input of the transistor we just replaced, and we want to peak T402 for the biggest 38K signal there. And so now I'm hooked onto the base of TR402 that we just replaced, or 403 rather, and I've had to adjust the sensitivity, and we see that we have a big fat 38 kilohertz signal there. So we'll come over to T402, and we're going to peak that. Not much change, but what you can see is that the phasing between the two spots there, watch this darkened area here. See how it moves up and down? So we're going to center that right there, and that should be our correct phasing point. Okay, so let's go back to our dual channel. Let's turn up our modulation. All right, so now the last thing I'm going to do is we're going to go to the 38 kilohertz phasing coil, which is TR403 right here, and we're going to adjust this and try to get the best null. And we can see in one direction we get better separation than the other, and you want to peak it so that there's the greatest separation, which is about at that point. And then finally, once you've done that, then and only then should you go to the separation adjustment. And on a Sansui 2000, it's hidden inside the phono preamp board. I don't know why, but there's usually a hole covering it like that. That's your stereo separation adjustment. And so we're going to come down here, and as we adjust this, we see that we can null it out almost completely. That's pretty good. So in one way, you get a little bit of a peak in either direction. So you want to null that out best possible. That looks pretty good. And then when I switch to a left side, it's looking pretty nice there. So that's the quick and dirty way to do your multiplex alignment. So that part's done. So now the only thing left to do really, I'm going to do a kind of quick tuner alignment because my broadcasting is at 98.5 and we're reading 97.9, so the oscillator is obviously wrong. Let's do a quick check and make sure that it's not dial pointer misalignment, and it is. See how it never finishes the scale here? So let's move the dial pointer a bit. That's going to require that I take this off. Alright, there's our dial pointer. There's no glue holding this, so I'm essentially just going to grab it and move it a little bit, which requires two hands so I don't bust the string. So hang on a second while I do that. There, so I'm going to peel back the center one a little bit. There's less grip on it. And I'm going to pinch here, and I'm going to slide this over. And the goal here is to put it, I'm going to spin down to the bottom and see if we start at 0, and we do, and I'll show you that once I put it back together, and then back to the top right at 100. Okay, so let's clamp that back down, and now let me show you how it moves on the scale. So now we're at the top of 100, and we should be able to go all the way down to 0, and we can. And so now if I go up to 98.5, hey, it's at 98.5. All right. Now I'm going to do a complete alignment, and I'll show you a quick way to do that with these machines if you don't have the service manual or you don't want to do the full setup. This one works just as well and with fewer steps, so it just depends on how much of a perfectionist you are. So the first thing we want to do, I'm going to change this over to mono so we don't have any noise in our stereo noise in our IF signal. I keep leaving the hook behind, damn it. Alright, so we're going to switch over, and we're just going to make it so that we have one point here. Let's turn my light on. And so this uses the UPC 555. Also the UPC 703 works. You can see them in both variants. But anyways, you want to come to the output of the first IF amp. Hold on here. Alright. Had to answer a phone call real quick. So we're there at the output of the first IF, and I'm taking a look at the IF signal here. Let's get rid of our modulation here. So now, make sure I'm centered on channel. We're going to peak it with the actual tuner here. Find that center point. Alright. So now that we've got that reference there, what I'm going to do, I've got just a basic wire antenna on it. You can use whatever impedance you're going to use. I'm going to use a 75 ohm. So it's best to have it terminated, but since you're just picking stuff up out of the air, I'm just using a straight wire, and I'm doing it inductively from the generator, which is broadcasting. So I'm going to come over here to my antenna input coil, and we're going to peak the IF, or peak the IF signal we get here. Alright, and then we're going to go to our second one, which is just adjacent to it. Again, peak it. Didn't really need much. And we're going to go to our third one. A little bit of change there, but not much. And then finally, we're going to go to our IF matching transformer output, which is this guy right here. This is your oscillator, by the way. And I'm just going to peak that. Okay, now what I'll do is it's not reading an accurate signal, but yeah, let's get it a little bit closer to the thing there. That makes it happier. Okay, so now that we've done the front end and peaked the front end, now what I'm going to do is go to the second IF stage. shed some light on this there. So we're going to go to the same pin on the second IF, and we should now have about double the signal, which we do. So let's change our sensitivity so I can see it a little better. And then we're going to peak, assuming that doesn't pop off on me, we're going to peak the first IF transformer here. And there's a top and a bottom core. And my test lead keeps popping off. That's annoying. Let me hang this in a spot where it's not going to move around. Alright, so if I adjust the top IF there, we can see a little bit of change. Not much, it's pretty much on par. And then what you have to do is you take the other side of the tool, which just goes straight down into the second core, and we're going to turn the second core. Tiniest little bit of change there, not much. Alright, and then we're going to do the third IF. And we're going to adjust the second transformer. And you get the idea here. These are pretty much all peaked. They haven't really drifted off frequency at all. Let me go down into the bottom one. Nope, no change there. Very little change. If we turn it to one extreme, it starts to decrease a little bit. That looks good. And then finally, we'll do the fourth IF here. And we'll adjust the third one. And just peak it. Very little change there. The third IF also affects your muting and threshold, so just be aware of that. Don't tweak that too much. Now, for the detector alignment on this, it's best to modulate and watch the scope. So let me go back to 2 channels here, and let's modulate our, we're going to do about 50%. And again, we're not doing a stereo signal yet, and I'm going to decrease the RF power until we start to see noise. Okay, you see that? I'm starting to see noise there. And what I'm going to do is adjust, I'm going to tune the actual tuner, and we're going to see the noise symmetrically on both sides, like that. And if you can't see it, you turn down the signal some more until you start to see it, like that. Your goal here is to see noise on both sides. All right, so that's your true center point on frequency. We're going to turn up our signal generator just a smidge, and then since this doesn't have a center channel meter, we're going to adjust the detector for the peak tuning. Third one doesn't do squat. I must be adjusting the secondary because I can see on the scope the amplitude going down and getting more distorted, so we're going to peak that. That's probably the bottom side that I want. So let's move this up to its side. We got to get underneath here. And we're going to adjust the secondary, or the primary, and watch the meter. Nope, that ain't doing me either. So it must be the third IF transformer or the secondary that adjusts the meter. Nope, it doesn't. So we'll put that one back, and then we'll just re-peak the detector here. Alright, so scratch that idea. It doesn't work the same on this one as it does my 4000. There's a separate meter adjustment for that, I guess. But that's how you really adjust it. You look for symmetrical distortion, and then you peak the detector coils for the greatest amplitude and least distortion. So, alright, let's put this thing back down. And now that we've got that all happy, then we'll retouch the stereo alignment. And I don't think I'm going to need to do anything except the phasing. So let's introduce a pilot signal. We got some noise there. Let's increase the RF so the noise goes away. And nope, don't need to do squat there. That just dials right in. All right, great. That's just great. Okay, so the FM's happy now. So now what let's do is the amplifier setups, which is going to require that we pull off the little top cover here. All right, so I've just got a signal feeding in from my signal generator through auxiliary. I've taken the little top cover off. You've got 4 potentiometers, 2 for center voltage and 2 for bias. Unless you know what you're doing, don't go a tweaking, otherwise you'll blow this thing up. So I'm going to show you how to do it so you don't blow it up. All right, so the first thing we want to do is we want to get a signal on screen here, and we're going to just crank our volume up here until we start to see clipping. Let's go down 1 scale. All right, so let's turn this off so you can see it better. So we see we got almost symmetrical clipping there, almost, not quite on the right channel, which has slightly more gain than the left. So let's do the right side first. So I believe it's reversed on this. We'll find out. I think it's reversed, so let's adjust this very slowly. Nope, that is for the left channel, because I saw the left channel quiver. So you make it so that you can just see the clipping, and then we adjust this so that the clipping is symmetrical. Got a little bit of clip at the top, a little bit of clip at the bottom. Back the signal off a little bit more, and we got no clip there, and we got symmetrical clip there. All right, so let's go on to our left channel. Just pretty close as is. In fact, it's no adjustment needed there. All right, so let me grab the balance control and tweak this a little bit so that we can even up those. And then we'll back them off just a little bit. And that is our full power output there before clipping. Let's see what that is. And taking across the speaker terminals, that's 16 volts RMS on the right, 16 volts RMS on the left. And let's do a little math. And so we got 16 squared. That's 256. And 56 divided by 8. So that's 32 watts per channel right there that we're squeezing out of this thing. So that's about on par with what it's supposed to be. Let's see what the spec says. So the spec says it's supposed to be 39 watts per channel at 8 ohms, continuous. It doesn't say whether that's both channels driven or not, but I'm guessing that's 1 channel at a time, because usually it will say both channels driven. Given what this is, you're not really going to notice an audible difference between 32 and 39 watts, and I have my doubts as to if it really did 39 watts. Let's try 1 channel at a time. So if we just fade over to the right side, and then we crank it a little bit more till we run into clip there. I don't think it's that much more. Let's see. Oh, yep, it is. Let's double check that. No clip. Yeah, 18. So with 1 channel driven at a time, where's my little pad thing? Let's do some math again. Okay, so what was it? 18 times 18. 324. 324 into 8. That's like 40 and a half. So yeah, 30, it's on par. 39 watts per channel, but it doesn't say both channels driven. Both channels driven, you're getting about 32, which sounds about right for the power supply capabilities on this. So this thing's happy, because you can see That's not clipping now until I engage both channels, and then it sags and you lose some wattage there, so no big deal. Alright, let's go on to the bias. So one thing that bothers me about Sansui's is their bias adjustments. And because this is a totally stock unit, this holds some truth. But if you replace the output transistors and driver transistors with something that's more or less efficient, this procedure doesn't work. So basically what you're doing is you're taking the fuse out of the rail holder on the back panel, and you're attaching a milliamp meter across it, and you're adjusting current 15 milliamperes to 10 milliamperes. 15 to 10 milliamperes, really? We're going down at room temperature, or 20 to 15 milliamperes at 25 C or more. So like hotter. But all right, so let's do that. All right, so I got my milliamp meter hooked up here across the right channel fuse holder. I'm gonna take the fuse out right now, and we're gonna see what it's at. That's not right. That's right. We were above the 40 milliampere scale. Okay, so we're at 50 milliamps. So that's a little on the hot side. So we're going to come over here to our bias adjustment pot, which is that dude right there. We're going to adjust it down to, what is it, 20 milliamps. Okay, 20 milliamps at idle there. And let's go ahead and put our fuse back in here. Then we'll do the other channel. And let's do our other channel here. Let's take this out. And this one's at 38. So let's turn this down. In fact, let me see what I'm doing here. Let's get to that adjustment. Now, if at any time you see the meter start quivering and twitching like it's erratic, stop. All right, so there's our 20 there. Okay, we'll put our fuse cap back in, and then we'll check some voltages, and maybe I'll be able to prove a point here, but why I don't like this procedure. Okay, so let's relieve this, and then let's put our meter back into the proper position, because it's always a surprise when you don't. All right, so let's make sure we don't have any notch distortion first. We're going to go to about 1 watt. And it looks clean. Let's go to about 5K. Looks pretty clean. Got to make sure our tone controls are flat. There we go. Yeah, so no notch distortion. So oftentimes what you find is you'll get notch distortion if you've done any work in the amplifiers. And so let me hook some stuff up here, and I'll show you what I mean by crummy settings. Well, I can't say squat about this one, because this one's working correctly. But what will happen is, if you get different drivers and stuff in here, you'll notice that you'll get notch distortion, and you'll have to crank up the current demand a lot in order to get that to go away, because the efficiency or gains of your drivers are different. And what you'll see is like a voltage drop across the output transistors. Instead of having like 0.5 of a volt between the base and emitter, it'll only be like 0.3 of a volt. So just, yeah, check that. Particularly when you replace the drivers, it's just the old bias procedure doesn't work. Now what you can do if you've got a scope and a load is you can just turn the bias up little by little until the notch distortion goes away, keeping an eye on current and all that sort of thing. But anyways, this thing is really done. So let's go ahead and reassemble it. Alright, well there she is all back together. And I just wanted to show you this thing reassembled because it really is just an amazing survivor. It's got a little bit of a stain here at the bottom of the case, but otherwise, look at this thing, man. This thing is just minty. Original wood finish. It's never been refinished. The faceplate looks just perfect. The side looks pretty good. It's got a little ding there. But this is the original owner. He's had this since new. Bought it from the exchange when he was stationed in Vietnam. But just like the face is all pretty. It's not scuffed up. All the shine is there. Just really nice. And so, in addition to the stereo repair, the multiplex repair, he also got some new caps in the signal path for the phono and main preamp and some new transistors. So, just helping it along. I didn't do a video on that because replacing parts videos is boring. But yeah, this thing's happy. Anyways, hope you guys enjoyed the little troubleshooting segment. And we'll try to do some more videos as time permits. Thanks for watching.